All right. So another word, this is the last word problem that basically is the combination of two right triangles before we move on to compass directions. Okay. Um, so it's going to be a mix between this and the compass direction questions that you're going to learn about today. So two vessels are searching for a sunken ship in the middle of the Atlantic Ocean. They spot the ship at the same time while they're 7.92 kilometers apart. Vessel A spots the ship at an angle of depression of 31 and vessel B at an angle of depression of 53. That's like assumed that they're both at an angle of depression, and you can just imagine, right? You're at the surface of the ocean and your radar or your systems are looking down to try to find that sunken vessel, right? The first question is determine the distance between the ship and both vessels. So they basically want, if you imagine a sunken vessel, what would be the direct distance to either one of those vessels searching for the ship, and then calculate the depth of the ship is B. Okay, so let's start with our diagram. Okay, so I'm gonna just start with a diagram here. So if this is the ocean, right at the top, you have two vessels looking for it, and it doesn't matter where you put them. There's A and B, and somewhere down on the ocean floor, right, we have this sunken ship, right? So there's an angle of depression that both of them have, right? It says that, first of all, we know that there's 7.92 kilometers. Oh, it's not recording? What? Oh, okay. Okay, I'll mark you here in a bit. Okay. 7.92 kilometers is the distance between the two. And I keep reading. Vessel A spots the ship at an angle of depression of 31. So, right, there's a 31-degree between the horizontal and the line of sight looking down. So it makes sense that it would be right here. Okay. And the second vessel has an angle of 53 degrees like that. Okay. Let's call this C. Why not, right? It's just easier to have a letter, a variable attached to that. So across from capital B, you would have B, and this would be A here. And this is your diagram. You need to start with a diagram and see the triangle in it. Okay, so right, there's two right triangles basically combined and made this oblique triangle, right? And we need to find the distances between both of them. So let's go ahead and do that. We don't have a pair at first. This is an ASA, right? If you remember that, angle side angle. So we can find angle C no problem and have our pair. Okay, so angle C is 180 minus 31 minus 53. I'm just gonna do this here. There we go. Okay, so angle C is 96 degrees. And so that'll be part of my calculation. So now I have a pair. So sine of 96 over 7.92 is equal to, you decide which one you want to find first. I'm going to go sine of 31 here over A is 7.92 times sine of 31. So this part, everybody, at this point, you should know how to do this. Okay, solving should not be an issue. And A is 4.10 kilometers. On this side, I'm going to start with the same pair that I started the other calculation with. And this would be sine of 53 over b is 7.92 times sine of 53 divided by sine of 96. Like essentially the same as before, except for now you have sine of 53 in the mix, right? And that gives you 6.36 kilometers. I'll just make note distance between ship and, so B is between ship and vessel A. This is distance between ship and vessel B. And I'm just going to quickly check, does it make sense? The longest side is across the largest angle because we now know that this is 96, right? So this is the longest side, yes. B should be longer than A because 53 is bigger than 31. So it all checks out and it's within range, right? It makes sense. So that's how you do that. The hardest part would have been coming up with your diagram, which we call, that's interpreting the question, right? Like what is the question really saying? Where do the numbers go? And so forth. And now we're going to answer B, which is the depth. Right? How would you find the depth of this triangle? Yeah. Find the height, right? It's just going down, right? That's the only difference. So you have choices here, right? That's the nice thing. So the depth is really from this horizontal line straight to the lowest point, right? Like that's straight, like how far down does this go? It's just like triangle flipped upside down. So if you're coming from this side, you can go A times sine of 53, or if you're coming from this side here, the other vessel, you'd have to go B times sine of 31. And both of them would give you the height. Okay? So essentially, right, if you travel out of this angle, boom, you get the height there. If you travel out from this angle, boom, you get the height there. So, right, both of them will give you the same number. It's going to be A times sine of 53 or B times sine of 31. You have choices there. I found A first, so 4.10, right, times sine of 53. That gives you 3.27. And let's just try the other one. The other one is, and it will most likely not be exactly the same because we're rounding when we're finding the side length. Yeah, it actually rounds to 3.28 if you do it the other way, but that's not going to be your problem, right? That's okay. It is what it is, okay? As long as you know how to do it. Okay. I will just make a note because you might look back down the road. You are essentially finding the height of the triangle. Okay, so I know that Keisha joined. Did anybody else join after attendance? Just type here, and then I can go back later. All right. We're now going to do compass directions. So I don't know if you've ever heard of bearings or compass directions. They say, right, travel north 25 degrees east, right? What does that mean? And that's what we're going to talk about today. So we're going to do a bunch of examples. So the first example is north 25 degrees west. What does that mean? So we're going to actually write down what it reads. North 25 degrees west. What does it mean? Right? Start measuring from north, then move 25 degrees towards the west. That's what that means. Okay, so you start north and then you measure 25 degrees, actually 25 degrees west, right? And at this point, I have flashbacks of sitting in my basement and making these lessons. Not a good memory. Okay. So if you consider your compass directions, right? Let's make dashed lines. We're going to fill in solid lines in a bit. Okay. So you have your north, south, right? East, west. Okay. This particular angle that it's referring to, right? You will make your north line solid, right? and then you will move 25 degrees towards west. Okay, 25 degrees, you move 25 degrees west, and then you grab your ruler and draw a line again. It's always from the origin here, and go out like that. So your actual direction here is you would, if you were flying a plane or a boat, you would actually be heading in this direction right now. Right? So this is your direction. But we will often stick with this angle because that angle will be part of the triangle that you will be getting once you put together that word problem and you interpret it. Okay? So the angle is formed between this, the north line, and the actual path that you're following, which is 25 degrees towards the west. Okay? Oops, my poppy is falling off all the time. So we're going to do another example here. Okay, so south 15 degrees east. And that reads south 15 degrees east. And what it means is start south. Okay, start south. Then turn 15 degrees eastward. And there's again north, south, east, west. Okay. Now, so let's make this angle. So south. So if this is your origin, this is south. You're gonna move 15 degrees east. So it's just 15 degrees, right? So this would be the angle. This would be your direction right here. And we're gonna try to put the 15 degree in there, right between the south and the actual direction. Okay. Another thing I want you to keep in mind is that this compass follows you wherever you go, right? North, south, east, west stays the same no matter where you go. Like if you were to go over here, you could start that again and keep going south 15 east, you would continue in the same path. Okay, so let's do one more, at least one more. West 30 degrees south. It reads west 30 degrees south, start west, then turn 30 degrees southward. So this is different, right? So far it was only north-south at the start. It doesn't matter. In this case, you're starting with the west. You're starting westward, and then you're going to turn 30 degrees towards the other, right? So let's make our compass here. North, south, east, west. Okay, so you're starting west, so you can kind of make this a bit, like, can make that solid here. And you're turning 30 degrees towards south. Right, so you would turn 30 this way and then draw your line. And the 30 goes in here. It's between west and south, basically, right? So this is your direction. You're moving in this direction, but the angle formed is right here, okay? And I'll just do another example right here. East 67 north. And we'll just try to so you'd start east and then turn 67 degrees towards north, and then that's your direction that you're actually taking. And the angle is right there. Could you refer to this as north, right? What is it? 3 to get to 20 north, 23 degrees east. Yep. Yeah, it's the same thing. North 23, it still adds up to 90, right? So keep that in mind. All right. Moving on. And so I'm going to give you some cases here, okay? In some instances, you will have multiple compass directions given. Here is how it works. This is in general. Could there be a case that falls outside of this? Yes, but when you get to that point, you will know what to do with it. Okay. Example 1, travel north 30 degrees east, comma, then turn north 50 degrees west. So it's a scenario, it's a very short and summarized version of it, right? But you start your path going north 30 degrees east, and then you turn to a different direction, you change directions north 50 degrees west, okay? This is common for, boating, if you're an ocean or lake or something, airplanes, if you're traveling through the forest, right? If you're hiking, you can kind of do that, right? If you're driving, not so much, right? You can't just plow through buildings, right? Because that's your direction, right? You can't do that. So let's see what this would look like as a diagram. So you have to be spatially aware, right? North 30 degrees east. Which way are you traveling? Like on your piece of paper, where would it make more sense to start? Here or here? Well, Northeast is, right? If you're going north and east, you're going this way. So it would make more sense to start somewhere over here, or else you'll run out of, and you'll learn the hard way. If you don't realize that, you'll be like, oh shoot, I'm running out of space. I need to erase this and start over. Not a big deal, right? But what you do is, let's say you are right here. You're starting there. Make your north-south, like it's like an imaginary, right? We're imagining, right? Your compass directions are still there. And so you want to see which direction are you going to travel, okay? You're going to travel north 30 degrees east. So we're going to keep this north there. We're going to turn east 30 degrees. And we're going to put the 30 there, right? North, and then you change 30 degrees eastward. That's your line right now as you're traveling, okay? And then it's saying, then you turn. So they don't tell you how long you travel in this direction, but they tell you you're traveling in this direction. That's the main point right now. Then you turn. So you make another point right here. You went from here to here. This is like your point A. This is your point B here. Then you turn. Well, what does that mean? It literally means do one of these again. Could be small, doesn't have to be, right? Depending on how much room you have. And if you need to start this over, then do it, okay? You're going from A to B in this direction, and then you switch paths. Now it's north, 50 degrees west. That means that you're starting your measurement going north, and then you're going to go 50 degrees, and you kind of have to, halfway would be 45, right? So 50 is a little bit more. So this is 50 degrees, and then you travel this way. We don't know how far, but we're just going to make it stop somewhere over here. Okay. I will tell you this, okay? So pay close attention when you're doing your diagram, because somehow diagrams do matter how you draw them. A lot of students will draw it until they're kind of aligned with where they started. And that's not a safe assumption to make. More often than not, you're actually not going to, you're either going to go past or you're going to stop before. So I would just make sure whatever you do, don't make it line up perfectly, because then you make an assumption that later on you'll see is not the right one. Okay, so what happened here? Started, then turned. What I need you to remember here is that, for 1 second, I'm just going to make sure I get this right. Yeah. This line, the north-south, they're parallel lines. This line right here, the north-south line that you had here is parallel to the north-south line here. Does that make sense? I hope so, right? North and south, no matter where you are, if you're here or here, they are parallel to each other. Okay, so this line right here, the dashed line here and the dashed line there, they run parallel along. It doesn't matter how far apart you are or how close together, north and south stay parallel. The same can be said by these two here. The east-west line always stays parallel. Okay, but what I'm going to do here is, this is why I do chapter 2 before I do this chapter here, because the order really most of the time doesn't matter. What the 30, how could it jump over to this side over here? What is this angle and this angle? Anybody remember? Alternate interior, that's right. So you can transfer this over to here. I'm not going to ask you to tell me why. At this point in this chapter, I don't care. If I asked you specifically, justify it, of course, but We know that if this is 30, then this is 30 here as well. And by that reasoning, do you know what this angle is in here? This is 180, right? So 50 and 30, that's 80. So this would be 100. Okay. So I'm going to bring this out here and say that 180 minus 50 minus 30 gives you 100 degrees. So you actually found, by doing this, you were able to find that little angle that was in between, which is actually, and I'm going to tell you that secret, it will end up being part of your triangle, right? So you want to know this one right here. So that's one of the cases that you can encounter. So maybe I'll say that this: north, south, and east-west lines are always parallel, okay? And that might help you find angles that at first may seem like can't do it, right? I'm stuck. Okay, continue. Example, this is the second case. Travel south 40 east, turn north 60 east. Travel south 40 east, then you're going to turn north 60 east. So again, I'm going to go south east. So it makes sense to start somewhere over here, right? Because you're going to travel here. So make a dot, that's where you start, and you have your little compass there. Okay, you being at the center of that compass. So you start your measurement at south because that's the first letter, and then you turn 40 degrees. You don't want to turn 40 just yet, do you? And you draw your line there. Until such point where you're going to have to turn. In a word problem, they probably tell you how far you travel, right? But if not, just you know your direction and you just make it stop at one point. And now it says north, now you're turning. So here, you do one of these again, and it's north 60 east. So north is here, and we're going to go 60 degrees from there towards east. And you draw your line there. 60 there. And you stop. Notice that I'm not stopping perfectly lined up with where, right? I'm not going to make it go all the way to here. I'm not going to do that, right? I'm going to purposely stop there because I don't know. You're making an assumption that is not there. Anyway, so your triangle, you can clearly tell that these two solid lines are actually part of the triangle. So you would need to, you have half, it's not quite half, right? We don't know what it is, but you have the 60, you need this little spot here, okay? How would you be able to do that? Parallel lines, don't you love them, right? This line is parallel to that line, right? So this one, it's almost always going to be alternate interior. I would want to say always, but every time I say that, it bites me, okay? So this is 40 here. And yeah, it's alternate interior, right? You got that. Alternate interior angles are congruent. Okay. And now you know the angle here at this intersection, you know that angle, it happens to be 100 again. Just a coincidence, okay? So you know that this whole thing here is going to be 100 degrees. And now you have the angle. A lot of students think, oh, it's 60. 60 is this whole thing. It's like, no, 60 is just north, 60 east, right? It's just that little piece here. You need that other one there. And that's that. So that's the second case that you will encounter. Easier than the first case, because the first case you had to do the alternate interior thing. Then you had to subtract that, like the two angles from 180 to get the middle, right? This is just as easy as bringing it over than adding. And the last case. Will I fit this on here? Yeah, I will. Travel west 70 south, then turn south 20 degrees east. Oh no, it's snowing. You can see flakes. Okay. All right. So I'm just in my head, I'm just stopping. I'm pretending to be you right now. It's like, how should I start this, right? You're going west that way, right? Then you're going to turn south, okay? So it's probably a good idea to start somewhere here, right? Somewhere over here. So I'm going to go like this and like this. This is where you are, right? So you're going to go west, so that's your starting point, and you from there you turn 70 degrees, and you draw your line going with that angle, right? And then you turn. So at this point, you make a point there, and there's your compass again. It follows you wherever you yeah. So we're turning south 20 east. So that this is my south line, and I'm just turning 20 here, right? So 20, it's not quite as bad, right? So there it is. So the 20 comes in here. And I just stopped there because I don't know, right, where I'm going. So what's happening here? I'm going to somehow try to use this 70 and transfer it over to my new compass here, right? That's what you want to do. You want to like combine it all. So you bring from the first one, you bring it over to your second, to that turn. Okay. So what I'm going to look at this. This is parallel to that one. Okay. How's that going to help me? Well, we'll see. Right. So this is parallel to that. So the 70 comes over here. Again, alternate interior, absolutely, but it's only this sliver here. Okay. And how am I going to find that other one that's appearing here? Did I not do this right? Oh, yes, yes, yes. I'm just trying to think. How did I explain that? Okay. How would you find this sliver here? Because it's between this and this. You still need to know that part. Anybody see that if you're in class? How could you find that blue part? Yeah.
Well, you know that between south and east is 90 degrees.
It's 90 here, yeah.
And you heard from 20, so you just have to go 90 minus.
That's right. So again, this piece right here is going to be 90 degrees minus 20, right? Because we know that between east and south, it's a 90 degree here. So that's 70 degrees, right? And now it's quite busy here. Whole angle, that whole angle there is 70 plus 70, which is 140 degrees. Both end up being 70 and 70. That's just a coincidence, right? If this had been 10, this one here, then this would have been 80, so 80 and 70 is 150, right? And so forth. So the alternate interior is your friend. Notice that a straight line is always 180. And obviously you've got your 90s there as well. Okay. Now let's put this into practice. Let's actually do a word problem for this. Compass directions, word problems. Don't worry about the 1.9. That's like my own internal numbering system. All right, so let's give this one a try. So this one obviously involves a compass direction. You should make note of that right away. It's like, oh yeah, this is compass direction. A couple of things to highlight too. They give you the distance you travel. And when it says something is directly due south or due north or due east, that means it's, in this case, it's straightly down south of you, like you're perfectly lined up, right? Like you are up here and somebody's straight down south. It's actually very important because it's a reference, right? If somebody's straight down west of you, you're perfectly lined up with that person, okay? East west wise, right? Like so it's a horizontal line. This one, in this case, a vertical line that connects them. Very important. Because if not, you didn't know exactly, is that person directly, are they perfectly lined up in a vertical line or not, right? So it's a vertical, right? There's a vertical line connecting them. Okay. All right. So let's try to interpret this. So a canoe leaves the dock and travels 3.5 kilometers in the direction south 46 west. So you're trying to think, right? Just southwest, so you're going this way, right? So start your diagram somewhere over here. So we consider this our dock, right? And from there, you're traveling south 46 west. So south 46 west, that's about there, right? And then you draw your line. And it tells you that you're traveling, you don't know exactly how far, just draw a line. And put the 3.5 on there. We don't know yet where it's going to go exactly. You may have to redraw or change things, but we know that that distance is 3.5 kilometers, right? A second canoe leaves the same dock and travels 4.8 kilometers until the first canoe is directly due south of the second. Okay? So this is the first canoe. Okay, first, putting that down. Canoe. A second one leaves, and it doesn't tell you which direction, it just tells you the distance, right? It just says that it's traveling 4.8 kilometers, watch, right? But it does tell you until the first one is directly due south of the second. So with that logic, you would have to travel this way, or somewhere above it. You would have to be above it if you were the second canoe, okay? So I'm just gonna, it doesn't matter which way you go, but I'm gonna go this way. And I'm perfectly lined up. Like if this is the north-south line, it's not straight, sorry, I'm gonna redo this. It's perfectly lined up. So in this case, you can make that assumption that the two canoes are right on top of each other like that. Second canoe. And we also know that it was 4.8 kilometers. Okay. So now we have all the info on here. We only have two sides and we don't have an angle yet. How would you come up with an angle in this case? Well, you want to try to bring an angle into the triangle, okay? So let's see what we can do with alternate interior here. We know that this line, which is the north-south line, which is here by the dock, is parallel to this line. And we know that because they told us that this is a vertical line by saying that one is due south of the other. We know that this is a vertical and we know that these two are parallel. Okay. Therefore, this 46, thank you very much, right, comes in here. And now you have an angle and two sides, which is all you need, right? And you have a pair, more specifically, you have a pair. So now you know it's a sine law scenario, okay? You have a pair, sine law, okay? So we start with, so this would be a mark, by the way, folks. If you identifying this as one full mark, because it's a concept, okay? And it all depends on how you drew this. Mr. Dirksen, what if I had drawn a line, like what if I had gone here? I'm still, the first one is directly due south of the second. Yeah, it's okay. It's okay. Don't sweat it too much. It will work. And so don't freeze, okay? Just try something. And if it doesn't make sense, you try the other way. Sine of 46 over 4.8, that's my pair here, is equal to, what do I want again? The distance between the canoes. So let me see, can I do that right off the hop? No, I can't, right? I don't have the angle, I don't have the side, but I do have this side. So I'm going to find this angle up here. Okay, let's put some labels on this before I even start this. So I don't know if we want to call this A because that, that was the starting point. Then we went B and then the second canoe came up here, right? You start with the dock, the first canoe, then the second canoe. So there we have it. Okay, so we're going to go sine of C over 3.5. Okay, we cross multiply. We know we're going to have to use the inverse. Okay, over 4.8. Angle C is going to be sine inverse of this, which I know is going to be 0 point something because Mr. Dirksen told me so, because if I don't, I made a mistake. And the answer key is somewhere, and I can't look for it now, so I'm just going to do it right here. Or this keeps going. Angle C is 31.64 degrees. So that's part of my answer, but it's not the final answer yet. So what I would like you to do is when you do that, right, now we need to find angle A. So angle A is just 180. Show me the work, right? Minus 31.64. That's 102.36. Which is also part of my work, right? So now I'm going to go sine of 46 over 4.8, which is the one I was given, right? Or that I found, that pair. And I'm going to go sine of 102.36 over lowercase a. Okay. Lowercase a is 4.8 times sine of 102.36 over sine of 46. And I hope that's the longest side of all of them, right? Because it's supposed to be. 6.52 kilometers distance between canoes. So this would probably have been a 4 to 5 mark question because of the interpretation, finding this. If it's too easy, if it's too good to be true, double check, right? Like what happened here, right? So there you have it. Okay. I have another example that I probably only will have time to get you to copy. We won't be able to solve it, but that's fine. Then at least I have it ready to go for tomorrow. Before I do that, I'll give you the homework. Okay. So just write this down. Homework. I'm not going to give you a whole lot of questions. So page 126, right? Page 126. We're going to go 12 on that page, and page 129, questions 8 and 9. These are mainly compass direction questions. If you run out of, if you didn't do the first batch that I gave you last Friday, go do those as well. Okay. So write this down. Take a screenshot of it. And maybe what I will do as well is, because I'm going to go over it tomorrow, is the one I'm making you write down, you do that as well. Plus class example, that one will be boat and supplies. Or you can just do arrow down that one. There it is. It's showing up at the bottom of your screen. A boat is delivering supplies to two lighthouses that are 12 kilometers apart. It does not say that they're right beside each other. Notice that. It just says they're 12 kilometers apart. So the way you want to draw it, it's up to you. At a distance of 9 kilometers from the boat, lighthouse A is located at north 30 degrees west, and lighthouse B is located north 50 degrees east. Distance unknown. And there's an A-B portion to this. Okay, so the homework in the textbook and this question that you're just writing down, which I'm going to go over tomorrow.